Hello, welcome you all. Uh, Another session on undamped free vibrations of single degree freedom system. I would like to consider one more single degree freedom system known as compound pendulum. So, a pendulum is basically anything which is suspended and which is a body which is free to undergo free oscillations. That is called as a pendulum. Okay, so here this also is a pendulum. I have a body. Okay, so the mass of this body is distributed throughout. I do not have a point mass. So in a pendulum, if you have point mass, then it's called a simple pendulum. If the mass is distributed, it is not point mass in a pendulum, then that pendulum is called as compound pendulum. So imagine this is a irregular shaped body and its mass is M and its center of gravity is G. So how do you find out the center of gravity? A very simple way, in a true way, or so the simplest way. So imagine that this is an irregular body, though it is a rectangle shape. I can easily find out the center of gravity. Knowing a regular shape, it is a rectangle, join the diagonal, and the intersection is there, the center of gravity. So imagine that this is irregular, very easy. Then you suspend it at some point. So you hold it, then you draw a vertical line. How do you draw a vertical line? Probably you can take thread and attach a heavy, I think you might have seen Gaundi people. They have thread and a heavy bob inside. Okay, so similarly, you take the thread and the heavy bob inside, then definitely that line is vertical. You draw a line. You know that the center of gravity of this is along this line, vertical line. Then hold it somewhere else. Then you draw one more vertical line. The intersection of the two lines is nothing but the center of gravity, and that now the center of gravity of this body has been already found out. G is the center of gravity of this, and O is the point of suspension. That is the point about which the angular motion or vibrations are going to take place. Okay, now I am supposed to find out what is the natural frequency of this body. Okay, so now as I know that, so before I really proceed with the vibrations, free vibrations, etc., I would like to say something about moment of inertia. Moment of inertia of a body. Okay, so J. So this is what I am interested to know. JO. In this case, the moment of inertia of this body about an axis passing through O, perpendicular to the plane of the board about this axis. This is what I call it as JO. Then I have something what is called as a J suffix G. What is that? Moment of inertia of this body about an axis passing through G, perpendicular to the plane of the board about this axis. This is what is called as JG. JO and JG, they are related by a parallel axis theorem. I hope you all can recall what you have studied in your applied mechanics or maybe in your PUC somewhere. JO is equal to JG plus the mass multiplied by the distance between the two axes. One is the O axis and G axis. O axis is this axis and G axis is this axis. And what is the distance between these two axes? In this case, it is nothing but OG. OG is the distance. So this is what we call it as the parallel axis theorem about moment of inertia. This is what we are going to use in our discussion, and that is why I have just mentioned about you. Okay? So I don't want to go in detail about this, the parallel axis theorem. So now let me come back here. So what I have a body. I have made a small hole in that body. Then I have something what is called as knife edge. I have something like this. This is how the body is. Okay. So I have a hole here, and probably the body is something like this. So this is what inside the hole, inside here, what you have here, this is what you see. So that when I oscillate it, I have oscillation about a point. That's what I ultimately want. That is why I have inside here. Okay, so understood. The mass of the body is m. That I can easily find out. I can weigh it and find out what is the mass m. That is known. Then the center of gravity also I can easily find out, and that also is g. Then I have suspended it, and I know that when I suspend, and this is the equilibrium position right now. What you see, whatever you see, is the equilibrium position right now. This line O and G, OG is vertical line. So this is the vertical. Okay, now I set it into vibrations. How do I do it? Take this body and move it here. Then this body is going to oscillate. Okay, so now when this oscillates, when it is oscillating, arrest it at some position. So at some position, then let me assume that this my OG line is somewhere here. So this is my new position of G. This OG has come here, then accordingly the body has come something like this. It is very difficult for me to draw that. The body is something like this. It is very difficult to irregular shape and exactly repeat it. It is not possible. That is why I am showing only the OG line. So the complete body I am not showing. I am showing only the OG line. OG earlier in equilibrium position like this. Now in the new position at t equal to t. This is the position, and let me show that this is theta. What is that? The angle of displacement, or this is the displacement, and let me assume that it is also having what is called as acceleration theta double dot. It is not stationary in this position, so it is having an acceleration of theta double dot. Okay, let me show what are the forces that are acting. In the new position, when the OG is like this, OG1, so I know that, what is this? What is this? This is the weight which is acting, m into g, that is the weight. And I don't have any spring, or I don't have any other force. This is the only force what I have. So this is only force, and this is producing momentum at this point, and because of that the rotations, this angular motion, the vibrations are taking place. So now I apply what's called as Newton's second law. So Newton's second law, so is it along motion along a straight line or angular motion? So here I have angular motion. So angular motion, for that you know that Newton's second law for angular motion is m equal to I into alpha. What is m? The sum of the moments due to all the forces about a point about which the rotation is taking place. That means about which rotation is taking place now? O is the point. So now I have to take moments due to all the forces about O. So in the direction of angular acceleration. Okay. So I have only one moment mg multiplied by this distance. So mg multiplied by OG sin theta. This is the distance. Now let me decide, is it positive or negative? This moment about O is in the clockwise direction. My moment theta double dot is anti-clockwise, that is positive. Therefore this is minus. Minus mg into OG sin theta is equal to I about O. The moment of inertia I about O into theta double dot. This is equal to, for small theta, what happens? This becomes minus mg into OG into theta. Sin theta becomes theta. So what is OG? G is center of gravity. O is the point of suspension. OG is the distance between the point of suspension and center of gravity. This is equal to IO is nothing but IG plus m into, what is the distance between the point of suspension, that is O and G, that is m into OG square, parallel axis, into theta double dot. Okay, so this I can rewrite it. That is Ig. Ig is again written as m into k square. What is k? K is called as radius of gyration. Okay, moment of inertia. Moment of inertia in general is mk square. Mass multiplied by radius of gyration square. Mk square plus m into og square. This multiplied by theta double dot plus m into g into og into theta is equal to 0. Probably I can take m here outside. So let me rewrite this. Okay, so probably I can divide throughout by m and m and cancel this. So now I can rewrite it. What is called as to have coefficient of theta double dot is equal to 1. So in that case, theta double dot plus g into og divided by k square plus og square. This multiplied by theta is equal to 0. Therefore, omega n is equal to square root of g into the distance O and G k square plus OG square. Okay, this is what is the expression for natural frequency. Many times this expression is utilized to find out what is the radius of gyration, or what is called as m into k square. M into k square is what? M into k square is the Jg, Ig. Okay, so many times this experiment, this information is utilized the reverse of that. So I have an irregular shape. What is the moment of inertia? I don't have any ready-made formula to calculate that. But this experimental result, I can utilize it. And find out what is called as omega n. Okay. So what I can do? So say imagine this is the body which is irregular. I want to find out what is called as Ig, or what is the value of k. So how I can do it? So take this and allow it to oscillate, small oscillations. Then take a stopwatch. Say for 10 oscillations, for 10 cycles, what time is required to find out? Say I have t seconds. T seconds are required for 10 cycles. Therefore, I can easily find out what is the time period. How much time is required for one cycle? T divided by 10. That will give you what is the time period. How much time period is required. So one time period, as you all know that F is equal to 1 divided by T. So find out this is so many cycles per second. So now you know that I don't want F, I want omega. Omega is equal to 2 pi F. So many radians per second. So please understand, you know T. So if you know T, you know capital T. If you know capital T, you know F. If you know F, you know omega. This omega is same as this. So therefore, omega is equal to omega n. Okay, now what are the unknowns? I know this left hand side is known. Then G, the acceleration due to gravity, which you can easily assume it. Then OG, yeah, I can easily measure. I know what is the point of suspension O, and I also know where is the location of the center of gravity. I can easily measure this OG, I know. This OG, I know. So what is unknown? Only unknown is k square. So you can simplify this and find out the value of k. So once you know k, then you can easily find out what is Ig. Ig is equal to m into k square. So this is how, though it is an irregular shape, we don't have any ready-made formula, I can find out the moment of inertia of this body using this experiment. Okay, I hope you understand. You have a similar experiment in your design lab 7th semester. So making use of this, finding out what is called as radius of gyration or moment of inertia. So this pendulum, this one is what is called as compound pendulum. Now let me move on to another problem. Okay, another problem looks like this. Okay, it is a system. Okay, I have what is called as, what is this? A spring whose thickness is 8. And what is this length? This length is what is called as the free length, because there is no load acting on it. I am going to attach a mass to this, and the spring will extend, and this is the new position of the mass. The spring will extend from here to here, and this is what we have called it as delta S spring, which is equal to mg divided by K. Okay, so this I call it as equilibrium position. Okay, all this we have done it already, and so many times we have repeated for other problems by other methods by the way. Why I am doing it again? Okay, there is a slight change here. Okay, this problem is a different one. The spring what I am showing is not massless spring, it is having mass. Okay, so spring has mass. Spring has mass, and say its mass is equal to say m suffix x. Okay, take this, taking this into account, taking this, what is omega n? What is the natural frequency of the system? That's what I am supposed to find out. Okay, the spring has a mass ms, and this is subjected to attached with a mass m, and the system is undergoing free vibrations. Then what is this thing? What is the frequency? The same question may be asked in the analysis remains same. It may be twisted. It may be put in other words. What is the effect of mass of the spring on the expression, on the natural frequency of the system? That way it may be asked. Okay. So now, okay, I set this into vibrations. I set this into vibrations. What? So I pull this mass, I up here, and it is oscillating. So arrest the mass. Arrest the mass at some position. Say the mass has, we say, is somewhere here. This is the mass, and this is at time t, and this distance with respect to the equilibrium position, the mass has undergone a displacement of x, and it is having velocity. Yes, it is having velocity x dot. So does it have acceleration? Yes, it has acceleration. X double dot is the acceleration. Okay, so let me assume from here to here, this distance, so I shall call it the L. So L actually is LF plus delta ST plus X, that is nothing but L. Anyway, I want that, and ultimately by the time I reach my end of the analysis, that L shall vanish. Okay, no problem. So I take the mass of the spring and then weigh it, and that is its mass is ms, that is already given. Okay, so now this problem I shall go for what is called as by energy method. Okay, I want to go for energy method. I want to use energy method and then analyze and find energy method. So in energy method, what do we do? The total energy is constant. Why I am taking energy method? We should not forget all the methods. That's why. So some problems I do by this, some problems I do by this, like that. Okay. Total energy is equal to constant, which is the sum of kinetic energy plus potential energy. Okay, so what is the kinetic energy? The kinetic energy, because of only translation, I don't have any rotations here, plus potential energy due to position. The mass is changing its position, therefore I have potential energy because of position. Then I have spring here in this system. Potential energy or energy stored in spring. The energy stored in spring is also called as strain energy. So strain energy is also a form of potential energy. Okay, so now let me come back here. This is what, okay, here. So I have kinetic energy because of small mass, whatever the mass you have attached. Okay, then I also have the kinetic energy because of ms, the mass of the spring. The spring also has mass. Okay, so every portion, everything, everywhere, the mass. I have a spring here. Okay, the spring also has mass, and that also is moving along the axis, and hence I have kinetic energy because of spring also. Kinetic energy because of mass or ms, or kinetic energy because of spring. So potential energy because of position, potential energy because of spring. Okay, now let me calculate. So this mass, I have a point mass. Okay, this ms is not a point mass. I have mass everywhere. So this is equal to half. So kinetic energy, as we all know, half mass into velocity square. Half m into x dot square. Half m into x dot square. Kinetic energy of the mass ms. So this is not that simple. Okay, so please remember the mass spring is extended here also. So from here to here, the spring is spread out. So though I have shown here straight line, it is not that I have coils only here and I don't have coils. It is not like that. The distance between the two coils increase, and from here to here I have coils continuously. Okay, so now the mass of the point, where mass of the end of this spring, the spring one end is here, the other end is here. So one end of the spring is attached to this m, and since m is having velocity x dot, and do you agree that this end of the spring is having a velocity x dot? And what about the other end of the spring? The other end of the spring is having zero velocity. Because this end of the spring is fixed to the plane and that is not moving, and therefore one end of the spring is having zero velocity and the other end of the spring is having a velocity x dot. So if I take any point here, that means its velocity is different. If I take anything here, that velocity is also different. That means the velocity of the spring is changing. Okay, therefore I have to be little more cautious to calculate what is the velocity. So therefore what I do, I consider a small element of length, what is called as dy. Say, let me call this as dy. This is at a distance y. This is at a distance y. Okay, what is the smallest distance of y? Smallest distance is 0. That means here. And what is the largest distance? Y is equal to here. If y is equal to 0, it is here. Y is equal to here, I am here. That means the y is changing between 0 and L, so that I cover the entire spring. Okay, so I have considered a small portion of this dy is very small. I would like to calculate what is the kinetic energy because of this small portion. So in general the formula is R into what is the mass of that spring, that is, what is the mass? That is ms divided by L. This is the mass per unit length. And what is the length there of my small element? That is nothing but dy. So ms divided by L into dy, what is that? that will give you what is the mass of this small element. And now this multiplied by the velocity of that element square. What is the velocity of that element? Okay, what is the velocity of this? The velocity here is 0. The velocity here is x dot. Okay, can I write it like this? See, x dot divided by L into y. If y is 0, what is the velocity? Velocity is 0. If y is L, if y is L, okay, if y is L, where are you? You are here. If y is L, okay, the velocity is x dot. So therefore, this is the velocity of that small element. This is square half into this mass of that element, this velocity. So what is this? The whole thing what we have done is the velocity of that small portion. But I want the velocity, not the, I want the kinetic energy of the entire spring. So what should be the limit? 0 to here. If you calculate this, this gives you the kinetic energy because of mass ms. Then potential energy because of position. Is it minus or plus? The mass has come down, therefore it is minus. That is minus mg multiplied by x. Then plus the kinetic energy stored in the spring. That is nothing but the average force. What is that average force? So at the equilibrium position, what is the spring force? K into delta St plus. So what is the spring force in this position? That is K into delta St plus x. K into delta St plus x. The whole thing divided by average 2. This multiplied by the displacement, that is x. Therefore, simplify this now. This is half m into x dot square. Okay, so some of these terms are constant here. 1 by 2 is constant, ms is constant, L is constant, L is constant. Okay, so plus some of them I shall take half ms as it is, then L as it is, ms and L. Then this x dot square I shall take it out, x dot square, then L square, then y, this y is changing, therefore integral of, so here this, okay, y square, and this divide, y square divide between the 0 and L, plus minus mgx. Okay, simplify this. This we have done it so many times. This is k into delta st plus k into delta st, 2k delta st divided by 2. That is k into delta st multiplied by x plus half k into x square. K into x by 2 into x, kx square by 2, half kx square. So I know that this and this they cancel. Okay, so now this is equal to half m x dot square plus half m s into x dot square divided by L into L square L cube multiplied by integral of y square divide is y cube by 3 and between the limits 0 and L. So I write it in one step, y cube by 3 and substitute the limits. Okay, so y cube by 3 substitute the limits between 0 and L plus half k into x square. Okay, so I shall continue the remaining part here in short. I shall quickly do it. Okay, so this is what is the left hand side? Left hand side is total energy which is constant C is equal to half m into x dot square And what is this? This substitute L cube by 3, L cube cancels. So this will be half ms into x, ms by 3. I shall write that 3 here with ms by 3 into x dot square plus half kx square. So I can rewrite it half m plus ms by 3 into x dot square plus half kx square. Okay, now differentiate it, d by dt of total energy. So I know that this is equal to 0. This is equal to half into m plus ms by 3 into differentiation of x dot square. This is 2 times x dot. I have differentiated with respect to x dot multiplied by x double dot plus half into k into x square differentiation 2x multiplied by x dot. Okay, this 2 and this 2, this 2 and 2. Okay, divide throughout by x dot and x dot. Okay, so now over, almost got it now. So what is the left hand side? Left hand side is 0. Okay, so what I have? M plus ms by 3 into x double dot. M plus ms by 3 into x double dot plus, what is this? Kx. Kx is equal to 0. Okay, so now to make x double dot coefficient 1, then we can bring it here, and then shall I write it straight away? Omega n is equal to square root of k upon m plus ms by 3. So what is the effect of the mass of the spring? So on spring mass system, that is the mass, the point mass is added by 1/3 of the spring mass. So that is what is the meaning of this. I hope okay, this is clear. So this is quite common in almost alternate paper. You have this kind of question, and for 10 marks I wish you to practice it. If you have any difficulty, anything to not understood, please let me know. I shall spend one more session on this kind of problem. So while teaching vibrations, we used to spend about 15 to 20 hours on these kind of things. Unfortunately, I can't afford so much time. I shall spend one more session at the most, or maybe 2 sessions. Then I shall move on and then discuss the remaining topic, what is called as damped free vibrations. Okay, right now, all the best. Take care.